So, did you do this problem, Maria?
Sir, actually, last class I had left like half an hour early.
Oh, yeah. So you got disconnected. Yes, yes.
Yes, sir.
Okay. So in this question, there are two media. One is of refractive index. Zoom out this one and then this would be easy. Yeah. So Aisha has to.
Sir,
Yes, yes, ma'am.
sir, is my voice clear today?
Yeah, yeah. Your voice is yes, absolutely. It is absolutely yes. Yes. Hello, Aisha. Assalamu alaikum.
Walaikum salam.
Okay, so we have just started, and did you do this problem, Aisha?
No.
Okay, so let us quickly do this problem, and then we'll move on to the total internal reflections. Yeah, let us quickly. So this idea is clear, right? To everyone, this idea is clear that whenever we are going from this media to the other medium, right? Let's say we are going from, so we are going from, let's say, N1 medium to N2 medium, right? And this refractive index is 1.5 and this is 1.3. So we are going from denser to rarer. So this one is denser, right? This is denser and this is rarer. So then, and let's say we are going from one and the incident angle, right? So this is the normal ray, this is the incident angle, and this is the actual path. This is the actual path and we are going to the rarer medium, so then this will be refracted
Away from the normal.
away from the, yes, absolutely right. So this will be away from the normal. So this is the angle of refraction, right? So if we
Yes.
write, yeah, if we write the Snell's law and we don't write the Snell's law like this, because remembering in this way it is difficult. So we write it in this, right? So N1 sine I equals to N2 sine R, right? And sine I by sine R, this would be N2 by N. So then we know all the values, right? We know
Yes.
how much is this sine I. So this is sine of 30. This is the first question. And then R we have to find out. This is N2 by N1. So sine of R, this is N1 and this is how much? Sine of 30 divided by N2. So this would be N1 is how much? 3 by 2. And then we have this sine 30 which is half. And then we have this N2 which is 4 by 3.
4/3.
So this 3 will go in the numerator. All these 2 will go in the denominator. So this is 2 and 4 into, right. Then this is how much? This is 9 by 16, right? So then angle of refraction sine R is 9 by 60. So R would be sine inverse 9 by 60. So this is the answer, right? For the case of when it is going from N1 to N2, right?
So,
Yes.
so we don't have to simplify the fraction.
Yeah, we can simplify the fraction, but this is good enough, right? So this answer is correct. No one will cross or cut the mark. So this is correct, right? Yeah,
Yes.
and we also have to not write the values because we don't know what is sine inverse 9 by 50, right? So yeah, sine inverse we can just leave it at this point. So this will be correct. Okay, in the second case, we have this N1 medium and N2 medium, and this was denser, this was rarer, and the ray is coming from here. So ray is coming from N2, right? This is the normal. This is the angle of incidence, and this was the actual path. So now it will go towards the normal. So then it will be like this, right? So this is my angle of R.
R.
So again, if I write N2 sin I, right, equal to N1 sin R. So sin R would be simply N2 sin I divided by sin N1. So N1 was how much? This was 3 by 2, right? And this is 4 by 2. So N2 is 4 by 3 into half, and then this is how much? 3 by 2. So this 2 and this 2 will cancel, and it will be 4 by 9. So we have sin I,
Sine
which is,
inverse 4
yeah.
by 9.
So the angle R would be sine inverse 4 by 9. This is how we calculate the angles, right? Okay,
Yeah.
so yes, please note down this part, and then we will do the total internal reflection, right? Please note down this. So today I want to complete total internal reflection and then the refraction through the spherical surface. So we have done the refraction through the plane surface, right? Rectangular
Yes, sir.
surface. Now we will do the refraction through the spherical. And you guys tell me whenever you want me to scroll down the screen.
Sir, can you please scroll down?
Yes, noted, guys.
1 second, sir.
Yeah. Yes, Mariam, what about you?
1 second, sir.
Yeah. Okay, so now let us understand. Yes.
Sir, 1 second.
Yeah. Oh,
Sir,
you are noting it down. Oh,
yes, sir.
personal.
Yes, sir, done.
Yes. Hello. Yes. Yes. Hello, Arslan. Assalamu alaikum.
Assalamu alaikum, sir.
Walaikum salam. Why are you sounding like so depressed? So what happened? How was
I
the
was, yes, I just slept very late. I was studying for the
Oh,
chemistry exam.
yeah, yeah. So, yeah.
It went okay, sir.
Twin Tokyo. That is good. Good. So, and what is the next exam that you have?
Physics.
Oh, physics. And what are the chapters?
Uh, so the chapters are these ones. So wait, I have it here.
Yes. Did you find the syllabus?
Yes, sir. The chapters that are coming are chapter 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11, sir.
Oh, so that is half yearly exam.
Yes, sir. It's one of those.
Okay, yeah. Okay, so we have yeah. So we are doing the first chapter. What I will do. So we completed the. We are currently doing the ninth chapter, and then we have done the eighth and seven and eighth chapter, right?
Hmm.
So yeah, let's see how much we can complete. Your why your background noise is very
Yes, sir. Sorry.
high. Yeah, please yeah, shut your door or yeah. So where are you? Where are you sitting? Please.
No, sir. My grandmother is watching something.
Oh, unfortunately, I have to say to you that yeah, please, we have to mute yourself today now, right? Because we can't say anything to our grandparents. Then okay, yeah. So we are just starting this TIR, total internal reflection. So in short, this is called TIR. And what happens in a TIR? So when let's say light is coming from a denser medium. So this is a denser medium, right? This is a denser medium, and light is coming from this medium. Let's say it is coming from here. This is the source, and let's say it falls on this surface, right, which divides this two. This is denser, and this is the rarer, right? So let's say at first this is the incident angle, right? Then this is the actual path. So light will go away from the north, right? So this is the first case. Now let's say the light falls on this part, right? Then what will happen that it will again. So this is the actual path, right? And light will go in this, right? So this is the angle of incidence. So you see that angle of incidence is increased, right? And then you reach such a stage that let's say this is the normal ray, and light goes in this way, right? So the angle of this refraction is 90 degrees. So that is called the critical angle, right? Critical angle is that angle where angle of refraction is 90 degrees, right? Now, when you increase your angle of incidence more than this critical angle, then what will happen? So then this light will bounce back from this surface, right? So this would be the angle of refraction. So this will bounce back, right? So it will reflect from this surface. Whenever you increase your angle of incidence greater than this critical angle, right? Then your light will bounce back from this surface, so it will reflect back to the denser medium. So that optical phenomena is called total internal reflection, right? So yeah, this is the total internal reflection. So it is an optical phenomena by virtue of which the light coming from the denser medium and going to and denser medium to rarer medium, making an angle of incidence greater than critical angle, then the light will reflect back to the denser. This phenomena is called total internal reflection, right? So there are, let's say, there are certain mediums, right, in which if you cross this critical angle, which have a very low critical angle, right? So if you increase your incidence angle greater than this critical angle, then the light will reflect, right? And one natural example of TIR is the diamond, right? So in diamond, we see a continuous total internal reflection. That is why the diamond shines, right? So the shining of diamond is due to this total internal. So what is the condition, or what is the critical angle? So let's say it's this is the denser medium. Refractive index of denser medium is N. And this is the rarer medium, so refractive index of rarer medium is R, right? So if we write for the case of critical angle, if we write the Snell's law, so Snell's law for critical angle, this would be how much? What should I ask? So Arsalan cannot unmute. So Aisha, you tell me, what would be the Snell's law? For the critical angle, what would be the Snell's law? We are going from this medium to this medium, right? So what would be the Snell's law? Yeah. NT into sine. In this way, we should always tell NT into sine IC. This is equal to NR and sine RC, right? So in this way, we should always tell sine IC by sine, and RC is how much? That is 90, right? Because this is from the normal, this is making an angle 90. So sine 90. And this is NR divided by. So then this would be sine IC. Sine 90 is 1. So sine IC is NR divided by N. So IC would be how much? This would be sine inverse NR by N. This is the critical, right? And for the different materials, we have different critical angles. Okay, so this is all about TIR, but there are two necessary conditions, right? Two conditions must be followed. So the required condition for TIR, one is that light should go from denser medium to rarer medium, right? So if we measure the TIR from, let's say we are going from the rarer medium to denser medium, then we cannot see TIR, right? The light should always go from the denser medium to rarer medium. And the second condition is that the angle of incidence should be greater than critical angle, right? And what is the critical angle? The angle at which the angle of refraction becomes 90. So that is so this is the definition and required condition of TIR. Is this clear, everyone? Any doubt?
No, sir.
Yeah, please note it down, and then we will talk about the use of this TIR. Yeah, whenever you guys want me to slow down, please tell. Yeah, whenever you guys have noted down, please, done. Whenever you guys have completed, please.
Sir, we're supposed to make the diagram.
Yeah, diagram is important. How can we understand
Okay,
that?
sir.
Yeah.
One
So
second,
how?
sir. Then.
And the rays are very important, right? Where the rays are coming from, and then where they are going. So for this one, for IC, this is going. Yes, noted, Archana.
Yes, sir.
Yeah, then please quickly note down this part, and then we'll understand the use of TI. Whenever you guys have noted it down,
Done, sir.
yeah. Yes, Archana, what?
Yes, sir. I'm just writing required control.
Okay. Aisha, what about you? Noted.
Yes, sir. Done.
Now, let us understand about where do we see the TIR effect and where we use this TIR. So, effect or use of TIR. So, first in the diamonds, right? It's clear share. It has one here, right? So the shining of the diamond comes from this TIR. And then in the desert area, right? So this effect or this phenomena is called mirage. So in the most of the Hollywood film or Bollywood films, you guys must have seen that some traveler in the desert when he is very thirsty, right? So he sees an optical illusion in which he sees some pond at some distance away from her, right? But when he goes there, he doesn't find any pond. So that is the optical illusion, and that happens due to the change in refractive index of the air, right? So whenever you have a hot condition, so the lower part is very hot. The space which is very closer to the ground, so ground is very hot, right? So the space closer to the ground is hot, and then the space above the ground, right, some height distance, so that is cold. So you have cold air and then you have this hot air. So there is this difference of this refractive index, and due to which this TIR effect happens, right? So this mirage, it is an optical illusion in the desert, or let me write it as hot desert areas, in which the traveler sees a pond ahead of him due to tear, right? And the objects around the pond, let's say tree or anything else, right? So they appear, the objects around the pond appear inverted. How does this happen? So you have this is a hot, right, region, and let's say there is this tree that is right. So and then there is this cold air, right? So when somebody sees, right, let's say somebody is seeing from here. Okay, so let's say somebody is seeing from here. So let's say this tree is here, right? So when the light will come, that is coming from this cold one, right? And then it will reflect back. So this tree will appear here, right? And it will be inverted. This would be inverted because this is the actual tree, but this will appear here, right? So due to this total internal reflection. Okay. So this is the mirage, right? So the due to this hot and cold and hot region, this tree will appear inverted, right? This is the mirage, which is an optical illusion, and the third one is looping, and this happens in so this happens in a very cold climate condition, and in which the object in the ground appear to be in the sky. So that also happens due to the TR, right? So the object will, let's say, ship or the other objects will appear to be in the sky. So that also happens due to this TIR. And then the fourth one is this the reflecting prism. So you have a reflecting prism, and this reflective prism can, so this prism can deviate the incoming rays at 90 or 180, right? So this is made up of isosceles triangle kind of shape, right? So these are made in isosceles triangle shape, which have 45-degree equivalent, right? So these reflective prism are made up of some glass, and those glass can be flint glass or that can be ground glass, right? So both these glass have the critical angle, which is less than 45 degrees, right? So it is made up of glass which have critical angle less than 45 degrees, right? So what is the use of this reflective prism? So this can deviate the incoming rays at 90 degrees, right? Or at 180 degrees. So let us see that how can this, so how this reflective prism can deviate at 90 degrees, right? So the case first, deviation of 90 degrees. So you have this prism, and the incoming rays are going like this. Right, so this is the incoming rays, and this is falling normally, so it will go perpendicular, right? Because the angle of this is the angle of incidence is 90 degrees, right? So this will fall perpendicularly. Now it is making an angle of how much? So let's say this is the normal, right? So this angle is 45 degrees. So then it will again make the 45 degree in here, right? So it will reflect back at 90 degrees. So this is the deflection of 90 degrees, right? And let's say there is this object. So this will make again, so the light rays are falling normally. And at here it is making, so this is the normal ray and this is 90 degrees. So again it will make a 45 degree. So it will fall like this was the object, but now this is your object, right? So this was the object, now this has become. So the size will remain same, but this object will be inverted. So this is the 90-degree deviation, right? When this ray is falling at this surface, at the so isosceles side. When the rays are falling at the isosceles side, so it will be deflected at 90 degrees. So this is the angle of deflection. But let's say they are falling. So in the second case, this is the isosceles triangle, and this is your 90 degree. And this angle is 90 degree. The rays are falling like right. So again, it will. This would be the normal. This is 45 degrees, so it will make a 45 degree in here, right? And again, this is the normal. So this is the angle of incidence. So this is the angle of, and again, it will make a 45 degree angle, right? So this is 45, so this will be 40. So it will come, right? This is the object. So it will go in this way, and then in here TIR will happen, and in here TIR. So TIR is happening at this surface and at this surface. This is 45 degree, and this is 90 degree. So in the first case, this was falling to this 90 degree side, right? At the equal side. But now it is falling to the hypotenuse. So then this, let's say this was the object. This was the object. So you can see that the object would be inverted. Right, this was the object, now it is inverted. And it is making a 180-degree deviation. So this was going in this way, now it is going in this way. So this is making a 180-degree deviation, right? So this was the example of optical prism. And the last use of this TIR is the last use of this TIR is optical fibers. So one user we understood about that it is, so diamond has the property of this TIR. Then we understood about this mirage. So optical illusion in the desert where you find some pond, right? And then the second one or the third one is this dooming, in which in the cold climate condition, the ships or the object appears in the sky, right? This is again the phenomena of this TI. And then you have this reflecting prism. So it has a certain structure at which this object is made up of some glass whose critical angle is less than this incidence angle, right? So if incidence angle is greater than this critical angle, then it will be reflected back. So this is reflected back, right? When it falls with the 90-degree angle, right, then it will go past this surface, and then at this surface it is making a 45-degree angle. So then it will reflect back with 45-degree angle. And now in here it is making a 90-degree angle. So it will go with the 90-degree angle, right? This is deviation of 90 degree. And then in 180 degree, you have this hypotenuse side. So this is falling 90 degrees, so it will straight past this surface. But at this surface, it is falling at 45 degree. So then it will make a 45-degree angle, so it will make a 90-degree angle. And then again at this surface, it is falling at 45-degree angle, so again it will go with 90-degree angle. And at this surface, you have this, so this is falling normally, so it will go past this surface, right? So at two surface, refraction is happening. And at two surface, reflection is happening, right? So in 180-degree deviation, two surfaces are you have two surfaces which are refracting and two surfaces which are reflecting. And in the case of 90-degree deviation, you have one and two surfaces refracting and one surface which is reflecting, right? So these are the case of this reflecting prism. And then you have this last use, which is the optical fiber. So optical fibers are some fibers, right, which are made up of some glass, and those are some quartz glass. And in the you have in the optical fibers you have two layers, right? One layer is this core, and the other layer is this cladding. This is cladding, and this is the core. So core has higher density, optical density. So core is denser, and this cladding is rarer. So when the light signal go from here, so they are always reflected, right? So these are totally internally reflected, right? So when you want to send some signal from here to here, so the full signal you will receive at the end of this optical fiber, right? So now you guys have seen your Wi-Fi internet, right? So nowadays you have a fiber connection, right? So those fibers are these optical fibers. And why do they use these optical fibers? Because there is no transmission loss, right? Because all the rays are totally reflected back, right? So then you get the full signal at the end. So some signal which you want to, let's say some voice signal or sound signal is translated into this optical signal, or some electrical signal are translated to this optical signal, and then you receive this signal at the end, right? So there is no net loss in the optical fiber. That is why they are preferred, right? So this optical fiber is made up of two parts. One is this core, and the other one is this cladding. So cladding is rarer medium, core is denser medium, right? And this core is made up of some quartz glass. So when you send some signal through this glass, then it is totally internally reflected back, and then there is no transmission loss in this transmission. So these are the uses of the TIR, right? Any doubt, any confusion in the uses of TIR? Yes. Yes, guys, any doubts in TIR uses?
No, sir.
Yeah, so please note down all these portion, and then we'll do the reflection through spherical surfaces. Right, so earlier you guys used to have those copper wire transmission of Wi-Fi, right? But nowadays you guys have these fiber connection in which you don't have any signal loss, any transmission loss, right? So now your internet is working fine, right? So all of you guys have this fiber connection, right?
Yes, sir.
Yeah.
Yes.
Why do you have these fiber connection? Because there is no transmission loss, and yeah, there's no connection. That is why the connection are being preferable, right? This is the travel, right? Yeah, whenever you guys want me to scroll down, please. Yes, noted, guys.
Yes, sir.
Then please, stop. This is cold air, and this is hot air, right? Right. We have this is the tree, right? And then the light rays are coming from this tree. So then it will be reflected. This is so from denser medium, this rays are coming, right? So you will see that this is the right. So this will appear in water. This is the correct time. This is the actual tree, and this is the image of the tree.
Sir,
Yes,
sir, can I join in 15 minutes? I have to pray.
yeah, you have to. Can you join in a moment?
In 15 minutes, sir.
Okay, yeah, yeah. So please go and join. Yes, noted this part. Yes, whenever you guys have noted it down, please tell.
Yes, scroll down.
This angle is 45, right? And this angle is also 45. This angle 45, right? And this angle, these are two parallel lines, so this is also 45. So for 90 degree, the incoming rays should fall on this equal sides, right? And for the 180 degree, they should fall on that hypotenuse, normal. Yes. Should I scroll down?
Yes, scroll.
And all the definition and all these things of optical fiber, you guys please look into that, right? So I have told you what happens in the optical fibers, but you guys please write that portion in there from there, and because that is beautifully written, right? So you guys please note down this optical fiber form. You guys know the working condition of optical fiber, right? So you have this pore which is denser and then this rarer. And whenever the light goes from denser to rarer media, so then light is reflected back, right? So TIR is happening in the core. So that is the optical fiber, and it is used in the transmission of communication system. And this optical fiber is also used in this medical surgery, right? So in surgery equipments, when they want to see inside the organs, right? So they insert this optical fiber in the body. the optical fibers are very, very important or very useful. useful. Okay, I noted, guys. Yes, guys, noted.
Yes.
Arslan, what about you?
Yes, sir.
Okay, so now let us talk about the refraction through spherical surface. Right. This is and very important terminology to understand that let's say this is a sphere, right? This is a sphere, and this part is called the concave part, right? And this part is called the convex part, right? So how do we decide which part is the refracting surface, right? So you always should remember that whatever part is in there in the rarer medium. So let's say this is some refracting surface, right? So this is denser and this is rare. So whatever part is there in the rarer medium, right? So that would be the refracting surface. So what part is there in the rarer medium for this case? What part is there? Convex or concave? What part is there?
Convex.
Convex. So this would be called the convex refracting surface. Right. And let's say you have this part, right? So let's say this part. So in this part, and this is the denser medium, and this is the rarer. So now this part is through this rarer surface, right? So this is concave. So then this will be called a concave refracting surface. And understanding this part is very important, right? So concave refracting surface. Okay, so you have two surfaces, convex refracting surface and concave refracting surface, right? And there can be two scenarios, right? So, but before we do that, this surface is a part of some sphere. So there would be some radius of curvature, right? So that is called this radius, and this is the center. Similarly, this would be some part of some sphere. So that would be called the center, and this is the radius of the curvature. So remembering these points, right? So there can be two scenarios. So refraction, refracting or the spherical surface. One would be from rarer medium to denser, right? And then you can have this from denser medium to rarer medium. Right. So there can be two scenarios that this rarer medium could be concave and convex. Right. So rarer medium could be concave or convex. So two scenarios, and denser medium could be convex or concave. So four scenarios, right? And similarly for this one. But all these four scenarios, the final result would be the same. So final result will be same. So if we do one condition, then all the fours are satisfied. Final result will be same. Okay. And for these four one also, the final result would be same. Okay. So we will do one case from here and one case from here. So we'll do one case of rarer medium to denser medium, and we'll do one case from denser medium to rarer. And then the goal is, so goal is to find out relation between the object distance, and image distance and the radius of curvature. Okay, so we have to find out the relation between U, V, and R. So, or let me write it in this way. So we have to find out these relation. Okay, relation between U, V, and R when the light is traveling from this rarer medium to denser medium, or from denser medium to rarer medium. So let us do this first case. Case first, from rarer medium to denser. We have this surface. This is rarer. This is denser. Right. And let's say this is the principal line. Right. So if light comes normally to this surface, then light will go in the same direction. Right. Light will not change the direction. So let's say this is the pole or optical. Let's say this is the pole. Right. Then this is the center of curvature. And in here, this is the object. So the object is placed at, and let's say these are the setup. So can you guys tell me that what kind of surface is this? What kind of refracting surface is this? Concave or convex one?
Convex.
Convex, right? So this is a convex reflecting surface, because this in the rarer medium, this surface is convex, right? If it would have been like this one, right? So then it would have been concave surface. Okay. And let's say that, yeah, we'll also understand about this one. So let's say we have this one, and this is the denser medium. This is the denser medium, and this is the rarer medium. So now what kind of reflecting surface is this?
Concave.
Concave, right? This is a concave. Good. So we always find out about the convex or concave reflecting surface through this rarer medium, right? Let's get back to this point later. But we have 5 minutes, so yeah, let us make the diagram. So light is falling at this point. Okay. So the normal to this one would be this radius of curvature, right? So the light passing through this one, this is your normal. This is your normal, and this is the incident angle, right? This is the actual path, right? This is the normal. So then light will go towards the normal or away from the normal. Yeah, nearer to denser. This is the path. This is the normal, right? The line passing through the center of curvature, that is the normal. So for this surface, this would be normal. For this surface, this would be normal. So normal ray passes through the center of curvature. Okay. So yeah, you can guys can also see from this sphere, right? So if this is the center, so this normal will always pass through the center. So this is the normal, so this will pass through the center. This is the normal, this will pass through the center. So similarly, at this point, when we draw the line, so that will pass through this center. Okay. So this is the actual path, and it will go towards the normal. So it will be like this. So this is where these rays are meeting, right? This would be the image, right? So this is the object, and this would be the image. So let me draw larger diagram. Let me draw image. So I will just write the image formation, and then we will do the calculation or relation in next class. So this is the angle of incidence, right? And this angle is angle of refraction. Okay. And let's say that this is X angle, this is Y angle, and this is Z angle. Okay. So do you guys know this relation that if we have, let's say, if we have this external angle, right, and this internal angle. So what is the relation between this exterior angle and this internal angle? So y is x plus z, right? This is the relation between exterior angle and the interior angle, right?
Yes, sir.
Yeah, so just remember that thing. So remember that for this case, for this triangle, let's say that AOC, right? For AOC, R is the external angle, exterior angle, and XY is the interior. And for let's say ACI, ACI, this is the exterior angle Y, and this one is the interior angle, right? So keeping that in mind, with yeah, some calculation. Okay. But yeah, so the time is over, so we will do this calculation. But yeah, please keep this mind. This image formation, please keep. So we yeah start from. Please note down the parts. And whenever you guys have noted it down, or when you want me to scroll down, please. And the next, yeah, so the next topic is very important, right? Derivation of this image formation. So please be there because the next one is very important. So we'll do the derivation in the next class. When we understand this image formation, then that would be easy to derive.
Sir, can you please scroll down?
Got disconnected.
That's
Done. Yeah, then please, okay, so this is angle of reflection, right? This is the normal, and this is the normal, and this is the refracted angle. So this is angle of reflection, right? And this would be angle I. Please, this image formation is very important. When we have understood this part, then we can draw this, then we can derive the formula, right? Yeah, there was this mistake that this is the refracted ray and this is the normal, right? So from normal and to refracted ray, this would be the angle of refraction. And this is same line, this is same line, so these are vertically opposite angles. So I So we will use this diagram in the next class and then derive the relation. Okay. Noted, guys?
Yes, sir.
Yes.
Okay, so you guys please log into your Learnivio account and see whether the test is activated or not. Yeah, please log in and tell me if the test is activated. And if it is not, then we can take the text next class. But yeah, please tell me whether this is activated.
It's not active.
It is active, yeah. So please take that test, right? You guys can leave
Yeah,
Arsalan
it's
and
not active.
it's not activated.
Yeah.
Okay, so yeah, then we'll take the text test in the next time, right? Stop it here and see you guys in the next class. So when is your next exam, Arsalan? When is your physics exam?